Hi, it's Peter here with Physics of Projectile Motion, Stage 1. A rock falls 7.5 metres. How fast is it going in that moment just before it hits the ground? We're going to follow certain steps as we go through these stages. Step 1 will be to do a diagram. Here's a rock, falls straight down, hits the ground. Done. Step 2. Which way will we say is positive, upwards or downwards? I'm going to choose to go upwards as positive. Doesn't really matter which way I pick, as long as whichever one I pick, I stick with it. Step 3, components. Now that's components of initial velocity, which doesn't really count here. This rock is starting from 0 velocity, both horizontally and vertically, so you can skip that one. Step 4, will I analyse horizontally or vertically? Well, not much choice here, I've just got vertical motion. So vertically, vert only, and there's 5 variables to think about. Now let's look at the question again. Fall 7.5 metres downwards, so that's negative 0.75 metres displacement. It doesn't say anything about having velocity at the beginning of the time, so we can assume that it was just released and fell beginning at 0 metres per second. What about the velocity when it hits? Well, that's what we'd like to find. And then acceleration. Well, acceleration due to gravity, 9.8, except upwards is positive and that acceleration is downwards. Which formula will we choose? Well, we'll choose the one that doesn't have t in it. It's this one. It's got the 3 variables we know plus the one we're looking for, so it's ideal. V squared, that's what we're looking for. It's 0, 2, and v squared comes to 147. And if you get the square root of both sides, you get 12 or negative 12. In this case, the answer is negative 12. Velocity is increasing downwards, so negative 12 metres per second. So how fast is it going in the moment before it's the ground? V is 12 metres per second downwards. So that's answered the question. Before we go, let's figure out t as well. There's no harm in finding out what all 5 variables are. T equals what? And now we know all 4 except t, so we could pick a couple of different formulas would do, but this one will do the job. We know it's 12 going down, 0, negative 9.8 t. T turns out to be 12 over 9.8, which is 1.2 seconds. So falling 7.5 metres, it takes 1.2 seconds to hit the ground. Probably about right. Okay, so before I go, I am just going to say, well, what about for those of you who are not really sure about my claim about not making any difference which way you choose is positive? So I'm going to choose down as positive, and let's see what happens. This time the displacement is positive 7.5 because that matches the positive direction. Velocity, still don't know. Now acceleration is positive because of our choice. So now what's the velocity come to? So you put in v squared equals u squared 2as, and you get 2 times positive 9.8 by positive 7.5, you still get 147. So your answer is still 12 or negative 12. So we're still getting the same answer. So as we go through, you could be trying that. You'll find that it doesn't matter which way you choose as positive. As long as you stick to it all the way through, you'll get exactly the same answer. So there's projectile motion and stage 1 calculation.